Okay, good. So let's start. This is worksheet 42. I also appreciate those of you who already completed exam and you're still doing the worksheet. Yeah, I saw your answers, so I will still comment accordingly. So first question here. Hey, Gordon, I'll be asking you lots of questions. You must respond. The rest of you also respond in the chat. Okay, but Gordon, you will need to be more active. You can even unmute yourself. It's fine. Okay, just see today's tutorial is just for you. Her eyes open so big. So there are 3 identical beakers. Okay, so one way for you all to really understand the question is to write down all the points. So 3 identical beakers, so they are called PQR. They are actually filled with equal amounts of water, right? Equal amount of water is one thing you must take note of, but they are at different temperatures. So these beakers were covered with identical lids. So it's a fair test, right? In this sense. And placed on a table in a room with a temperature of 28 degrees Celsius. Water droplets were formed, okay, for the beakers Q and R as shown. So the water droplets are here on the inside, okay, and then over here, it's on the outside. So Gordon, firstly, tell me, what do you think this topic, what topics are involved in this question?
The water cycle and temperature.
Okay, so it's about heat, right? Heat as well as water. So there are actually 2 main concepts or 2 main topics being tested here. Okay, yes. Yun Shen, you can. Yeah, while I'm going through this, you can type in the answer. Yes, thank you so much. Okay, which of the following beakers actually contain water which had temperature change as shown in this graph? So started off at this temperature. Okay, if I'm going to ask you many questions also, the rest of you also must answer in the chat. All right. So the temperature actually goes down, right? The temperature is dropping until this particular point, and then it stays the same throughout the rest of the time. Right, Gordon? Can see that? Can you tell me what is the horizontal line of temperature? What is that particular temperature? Do you know?
You mean the one that's like straight or coming down?
Straight. So if I were to draw, what do you think is this temperature?
About maybe like 50 degrees.
So high.
30
Okay.
degrees, 30-ish degrees.
Right. Actually, Rachel is correct. Thank you, Rachel. Right. Okay, no worries, Teja. Okay, this is 28 degrees Celsius. Why is that so? Some of you open your eyes so big. Do you know why? Quickly tell me if you know why.
Oh, I know.
You know, very good, Gordon. Yeah, because that is the room temperature. Remember, heat loss and heat gain will always take place until it reaches the same temperature for the 2 different areas. Yes or no? Yeah, Tamai, that's right. That's the room temperature. Tanishka also says it's room temperature. Okay? So whenever you see the temperature of some substance, either it increases, then reach a constant temperature, or it decreases and reach a constant temperature. That constant temperature is actually the surrounding temperature, the room temperature. Sometimes the room temperature can be 25 degrees Celsius. Sometimes it can be 35 degrees Celsius. Read the question properly. See, Miss Tay actually circle it, right? Yeah, so that's why I circled. Okay. Yun Xuan, no worries. I'm going to rescue you. Give me 1 second. So what is the answer over here for this question? Anyone? You just type in first, Yun Xuan, later I'll help you. All right? Yeah, okay. I have people typing in already. Answer is B, B, B. Why is it B? Why is it B? How come it's bigger Q? Gordon, want to try or not?
Because the water droplets are inside and they're above the water level, meaning that the water is at a lower temperature.
The water
Oh,
is
higher temperature. Higher
at a
temperature.
higher temperature, yes. Can you try to imagine if you have a cup of coffee and then you cover it? Let's say you went outside to buy coffee and they gave you coffee in a styrofoam cup, then they will cover. They did not fill coffee all the way to the top, right? So when you open the lid, what happens? Do you see a lot of water droplets dripping off the lid? Yeah, that's right. So that's because, okay, one thing is the evaporation of the hot water or the hot coffee. Okay. Another thing is there's also water vapor trapped inside the cup, right? And then it gain heat. And then when it touches the lid, it loses heat and condense, something like that. Chicken rice packet as well. Uh-huh. Yeah. If you are given the styrofoam box, even the paper they wrap up when you open the paper packaging, right? You also have a lot of water droplets dripping, and it's so annoying, right? It makes your rice a little bit soggy. I don't like it, when I have the rice at the sides being soggy. Okay, so that is because this is actually warm, or we can say it's hot, depending. Okay, the more water droplets you see, the hotter that water inside the container. Oh, Jakai likes it. You like soggy rice. Oh, okay. That's nice to know. Yeah, some people does, like my dad also. Okay, so when you have water droplets forming outside, what can you say about the temperature of the water inside? What can you say? It is actually very much colder. Yes, very good. So this is a lot cooler, or you can say it's cold. Okay. Imagine you take a can of green tea from the fridge, you put it on the table, kitchen table. Soon you have your can sweating away, right? Is it really the can sweating? No, it's because of water droplets condensing. Okay, so I'm not going to spend more time on this. So we are all clear. Bigger Q start off at these. The water inside started off at a higher temperature, probably maybe about 40 degrees Celsius or maybe 45. So it started losing heat, okay, and then reaches 28 degrees Celsius. Next question. Choose the one which correctly represents direction of blood flow to certain parts of the body. How does blood flow? Okay, the heart pumps the blood to all parts of the body, right? So that also includes our head. Okay, I'll show you another diagram. Okay, I found this diagram online. Okay, so you have the heart here. Okay, so these red colored blood contains a lot of oxygen. Okay, so you can see oxygen here. Then you can see carbon dioxide here, right? So the blue colored ones are actually carrying a lot of carbon dioxide. Okay, so the heart pumps blood, okay, to the arms, to the brain, to the stomach, to the kidney, to your limbs as well. Okay, so after that, blood also travels back to the heart. Okay, then the blood that carries a lot of carbon dioxide will then go to the lungs and dispose of the carbon dioxide. So answer over here is D. Can you see? Okay, because this line, the whole line, the complete line, okay, carries a lot of oxygen. All right, so these carries a lot of oxygen. Remember, you take in the surrounding air containing a lot of oxygen. The oxygen goes into the bloodstream. The blood then travels to the heart to be pumped to all parts of the body. Right? Then after that, the blood with carbon dioxide, with more carbon dioxide, will then flow back to the heart and then goes to the lungs. Can I go on? So far, okay? Gordon, you must be okay. I'm going to checking with you. The rest of you okay? Now, must be still serious lah. I know you're a bit more relaxed, okay? Yeah, but that's fine. Just keep trying. We're going to play a lot of the online quizzes also during the Head Start, just to yeah, just you have to always remember your topics in P3, P4, and P5 when you move on to P6. Okay, P6 is going to be a very, very busy year. Question 3, we have P and Q, these materials connected to circuits X and Y as shown in the diagram below. So the bulb in circuit X lit up, but the bulb in circuit Y did not light up. Okay, so this one can light up, right? But this one does not. Okay, this one on the right side in circuit Y does not. So what could materials P and Q be? Gordon, tell me, what is this topic testing you on?
Electrical conductors and insulators.
Wonderful. Okay, so you're talking about conductivity. Conductivity, we actually explore different materials which are electrical conductors or electrical insulators, right? So what is your answer over here? Let me see. A is the answer, correct. You got this wrong, no, Gordon? Yeah, you actually put down D, and I think you mixed up. You see, you chose rubber and then copper. You mixed up. It should be the other way around. Correct? Because this is actually a conductor. Right? This is insulator. Did you see that? I think you mixed up, you put it the other way around. Okay, answer should be A. Now you can tell me answer is A. But in the portal, I saw their answer is D. Be careful here, okay? Tomorrow, when you read the question, you have to be very, very, very careful. Don't mix up. Okay, Penny made 4 different circuits as shown below. So clearly, this is on electricity. All the bulbs in each circuit lit up. Arrange the 4 bulbs J, K, L, and M based on their brightness in a decreasing order. We have done a similar question before. Do you recall? We have done a similar question before. Yeah, so Tanishka nodded her head. Good. So which one will be the brightest? Remember, I told you you can explore this by using an application or a software called PHET. Yes, you can always explore that. Good. So if you go and construct all these circuits, right, using PHET, you are going to be able to see that M is the brightest. Okay, and then by right, we can end here because there's only one option with M being the brightest, right? But let's check. Okay, then is it followed by J and K, and then the dimmest is L? Let's take a look. So now you compare the number of batteries. Okay, so here you have 3 batteries, right? Here you have 2. Here you have 2. Correct? But yes, Gordon.
Can I just ask something? Shouldn't it J is the brightest because there's 2 bulbs and M has 3?
Ah, okay. You know why this one will be the brightest? You know why M? Okay, let me just explain to you. Okay, when you have this kind of arrangement in series, okay, whatever electrical power is actually being shared by the 2 bulbs. Okay, no matter how many units of electricity, they have to share half. So that means it's like 1.5 and 1.5. Can you see that? Whereas when you put it in a parallel connection, parallel arrangement, each of them will have 3 units. Okay, but parallel connection will also lead to the batteries dying very fast. Okay, so you want equal brightness, you put in the parallel arrangement. Okay, so now when I come to this sharing, right, this is 1 unit and 1 unit. Okay, over here, 2 divided by 3. So it's 2/3, which is 0.67. So if I'm talking about units of electricity, okay, this is how it works. So can you see the numbers now? And can you also see that L will be the dimmest because it's only getting 0.67 units. Ah,